Hello everyone, let us now discuss grid game, the question in LeetCode. So here we are given with a 2 into n size of grid. We have two robots. Robot 1 will take the maximum score and make the cells as 0. And the robot 2 have to traverse through this grid and take the remaining score. Let us take this example 254151. If this robot 1 is iterating from this index. So a robot can go either right side or down. If this is the point, it goes to down and goes for the right. Then what is the score gained by robot 1? 2 plus 1 3 plus 5 8 plus 1 9. But why I need this robot 1 score? It's useless because first robot wants to minimize the number of points collected by second robot. I just need to return the maximum score that can be gained by robot 2. So if I made 2151 as 0, 2151 as 0, then I am remaining with 5 and 4. That's it. Now robot 2 can only go through this, right? Only go through this and get a score of the robot 2 can get a score of 9. If this robot is going down at this index, then robot 1 goes through 2551. Grid will be changed to this 2551 as 0. Robot 2 has two choices. Either it can go forward and it can also go down and go through right. Then if it chooses this path, the score is 4. And if it is choosing this path, the score is 1. But the second robot also want to maximize the number of points it collects. It will take this path and the maximum score it can attain is 4. If I go through this path, then I can get 4 as a score for robot 2. Let me take another example to make you understand clearly. The first thing, what if the robot goes through this path? I am only concerned about the second robot score. I need to make it minimum. Now, if I take the down step at index 0, if I take a down step at 0, then the score for the robot 2 will be 5 plus 4 9 plus 8 17 plus 3 20 plus 6 26. Now let me take another step 2 5 6 7 4 2 5. I am not concerned about robot 1 score 4 8 3 6, and this can also be another path. Here I am only taking the score. This all will be zeros. So if it goes through this path, it is also made as 0. Then it can only attain 1. And if it takes the second path, 6 plus 4 10, 10 plus 8 18 plus 3 21. It can also attain by removing this element 5 from the total score 26. By removing this 5, then I can get this remaining score. I am comparing. If I take a down step at 1, 26 minus 5, then it will be 21 and 1. So it will take a path in these two, the maximum one, and it is 21. Robot 1 takes this path and gets down at this index. What is the score that can be attained by the robot 2 if 2 is the index where robot 1 gets down? It is 8 plus 3 plus 6. Do you need to do all this iteration? Because simply if I take out 4 from 21, I'll get 21 minus 4, I'll get 17, right? So I need to consider this 0, 1, 6 and so on. 6 plus 1, it is 7. So from these two, it will take the maximum and it is 17. Now, here I can attain a score of 9 and here I can attain a score of 14. At index 3, 14 and 9. From these two, the maximum is 14. Robot 2 takes the path either from here or from here at index 4. It will be 6, 1 plus 6 plus 7 plus 4. But wait, every time I am checking from starting to this index, how can I get this score? Simply by using a prefix sum. Only one possibility for robot 2. It is from here till here. And if you see here, the score is 1, but here it is 7, and here it is 14. And if I get the count, sorry, the prefix sum, if I get the prefix sum at every index, it will make the calculation simple. If I get the prefix sum for every index for this top at this index, I will cancel out the last and take the difference between the last and the current index, and I will take the bottom score at the current index. That's it. And I will change the result every time for every iteration. This is how you solve this problem. So that means you need two prefix sum arrays, one for top, one for top, and one for bottom, and it will store the prefix sum of every index. Now the result will be set to long max. As they said, it is minimizing the number of points collected by the second robot. So we need to check the minimum one every time. That means here it will take a path, sorry, it will take a path where it gets minimum. It is here 14. It is getting the minimum score for robot 2, so it will get down at index 3. That's it. So I need to get the result where it is minimum. Now the thing is, I will be iterating from I is equal to 0 to n, and the top sum, how can I get the top sum? That is top of n. As I said, the last sum, the sum at the last point, and it will be the difference of sum at the last point and top of I plus 1. And the bottom sum is the bottom of I. That's it. Here, as I said, up till here it will save the prefix, sorry, it will store the prefix sum at the current index. Now, after that, I will change the points. As I said, the robot 2 takes the maximum from both the paths, and this robot 1 takes the minimum for every point. Now, points will be the maximum of points, sorry, the maximum of top sum and bottom sum. Now, after this, the result will be changed to the minimum of result and points. After the iteration, we'll return the result. That's it. It is as simple as that if you know the basics of prefix sum. So let me write this code. So let me write this code. Initializing n is equal to grade of 0 dot size and vector long because it can go out of bounds or give a runtime error if I take int, because this uh, sum is also need to be written in long. So top, and also let me name it as bottom n plus 1 comma 0, and for int I is equal to 0, let me construct these two vectors. I is less than n I plus plus top of I plus 1 is equal to top of I plus grid of 0 of I. and the same with bottom. Bottom of 0, sorry, 1 of I. Now long result is equal to long max. For int I is equal to 0 to int I is equal to 0 to n I plus plus, the top sum is top of n, sorry, n minus top of I plus 1, and long bottom sum will be bottom of I, and long result, sorry, points will be the maximum of top sum and bottom sum. Now result will be changed to minimum of result and points. So if you like this video, share to your friends and subscribe to my channel. Thank you.